For number 3, particle moving questions. Here we have a particle moves along the y-axis. And then instead of thinking about x, you're thinking about y. It doesn't really matter. It's just the matter of shifting your orientation, looking at the bottom. This is going along the y-axis, and we are given velocity v of t is equal to 1 minus arc tangent e to the t. Okay. And we also say that at time equal to 0, t equal to 0, y is equal to -1. This is what we call the initial condition. Okay? And that's very important to remember. Alright, now part A says that find the acceleration. Now we understand the acceleration, A of t is just v prime of t. And so that simply means that we take the derivative of v. Now, taking the derivative of v is very simple. The derivative of 1 is 0, negative is negative. The derivative of the tangent is, arctangent is 1 over 1 plus u squared, right? Now, u in this case is e to the t. But we need to multiply by the chain rule, which is the derivative of the inside function. The derivative of e to the t is e to the t. So your answer A of t, acceleration, is now highly equal to negative e to the t over 1 plus e to the t. So this is your answer for acceleration. Oh no, that's not the answer. This is the answer for acceleration, but I shouldn't be boxing this perfectly. The problem asks for t equal to 2. So A of 2 is equal to negative e squared over 1 plus e squared. And that then is what you box.
E to the t squared.
Oh, square. Yeah. I'm sorry. Good catch. Squared. So to the 4.
Yeah.
Maybe I'll write this a little bit better. Negative e to the t over 1 plus e to the 2t. Okay, so that's the one we want. Okay? Good. Questions up to this point? We're okay? Okay. Okay. Part B. Here says, is the what?
It's speed.
Speed. Is the speed of the particle increasing or decreasing? Now you know that they're making it tricky, right? That probably has to do with what we just talked about earlier. Yeah. So here is talking about speed, whether speed is increasing or decreasing at t equal to 2. So at t equal to 2, so we have to figure out several things. Remember on the chart right there, the chart that we just produced on the board. You need to know the velocity, you need to know the speed, and then you need to know the acceleration. And you don't really need to know the actual value, you just need to know the sign. Right? You just need to know the plus and minus, right? So we need to know these 3 things. At what? At t equal to 2. So at t equal to 2, we have to figure some stuff out. Velocity. Now first of all, let's take a look at v of 2. So v of 2, if this is v of 2 will be 1 minus arctangent, so inverse tangent e squared. Okay? Inverse tangent e squared. Well, how do we know whether it is positive or negative? This is number 3, that means we can use a calculator. So I will go ahead and just use my calculator and I say, okay, 1. Well, let me make sure everything is in radian mode, okay? Everything is in radian mode. I say 1 minus inverse tangent e squared. Let me know what you have. Let me know what you have. Someone go out and down to keep it down a little. How close the board was. What do you have?
Negative 0.436.
Okay, so negative point what?
436.
4, 3.
Yeah.
It's negative. Now, so what do you think speed is? Speed at 2 is? Positive, yeah, positive 0.43, right?
Yeah.
Okay, now we also need to know acceleration, yeah? A of 2. Now we just have A of 2, right?
Yeah.
Just come up with, which is
Negative.
negative. So negative e squared over 1 plus e to the 4. I mean, you actually don't have to come up with the answer, the actual answer, but you can say this is the negative value, right? I can just simply say it's a negative value. So, with my nice little empty chart that I have in my mind, speed, velocity is negative, speed is positive, acceleration is negative, so speed is, that's right. Now, they want you to justify your answer or give a reason, then you can simply just say that velocity is positive and acceleration, no, velocity is negative, acceleration is negative, and therefore speed must be increasing. That's that simple. Then you get your answer, you get your for reason. Okay? C, part C. Questions up to this point before I move on? You got it? Okay, part C. Here it says for time greater than or equal to 0, makes sense. Time is always positive. At which the particle reaches its highest point. Find the time in which the particle reaches its highest point. Now, this is where you have to read between the lines or between the words. Highest point. What concept in calculus we talk about highest point? Maximum, minimum, right? And what do we use?
First derivative test.
Now, first derivative of what? Position, yeah?
Yeah.
Right? Because highest point is position, right? So highest point, we're doing the first derivative on the position equation. But the first derivative of position is what? Velocity. Right? We are doing the first derivative test on y of t, basically. Like position, how high, how low, right? Y of t. And first derivative test, so basically we're looking for y prime equal to 0. But y prime is velocity. Y prime is velocity. And we're saying equal to 0. And we're trying to figure out what are the critical points. Okay? So how do I do that? Well, so that equals 0. So you set 1 minus inverse tangent e to the t, and you set equal to 0. So how do I do that? How do I find out what this answer is? Huh? Yeah, calculator. There are two different ways to do this. You can set it this way. You can say, okay, 1 is equal to tangent inverse e to the t. Right? So what you can do, this is what you could do. Basically, you're saying that which point will 1 and tangent inverse e to the t will come together, right? Meet together. So you could say, you can set, use your calculator. Use your calculator. You could say, you can set y1 equal to 1. And y2 equal to inverse tangent e to the t, or e to the x. Your calculator can only have x. Right? You graph it out. And then you use second trace, which is calculate, yeah? Second trace and calculate, so you do calculate. You can pick the option number 5. Right? 5, which is intersect. And it will lead you to the graphical window. and say, okay, now which is the first function? You select the first function, and it will ask you, okay, which one is the second one? You select the second one, and then it says guess, right? And then when it says yes, then you move your cursor, arrow, you little blinking dot closer to the intersecting point, and then you press enter, and then it comes out with your with a value. Do you see it? What value did you get? So I'm going to go ahead and do that too.
Wait, why is the intersecting point the maximum? Why is the intersecting point the maximum?
No, not the intersecting point.
Oh, first one.
This is for this. I'm trying to find out what t will make the velocity equal to 0. That gives me the critical point. I do not know yet whether that's a maximum or minimum. Because why? Because I haven't done the first derivative test.
Okay.
I'm simply trying to find out that value. I'm doing all this just to get that value. You see? Right, so people think that calculator problem is easier. No, I don't think so. It's just more work on the calculator. Right? So what do you get? You get, what value do you get? 1.1?
0.444.
T is around what?
0.443.
0.443. Good. So here we have it. So that's your critical point, right? So you got 0.443. That's your t value, and this is your derivative value, y prime, which is b. Right? So at this point, this is equal to 0 for the derivative. So now let's take something smaller and put it in here. Something smaller, put 0. So e to the 0 is 1. Inverse tangent 1 is, what's that? Inverse tangent 1. So 1 minus inverse tangent 1, you get a positive value, yeah? You get a positive value, so it goes up. And then you pick a value that's bigger than 0.4, so let's use 1.
Yeah.
Right? So you get 1 minus inverse tangent e, you're probably going to get, I bet you're going to get a negative value. Come down like this. Right? You're going to come down like that. So here, you have an answer. Find the time, part B says, find the time at which the particle reaches the highest point. Well, guess what? At time equal to, at t equal to 0.443, y is highest. Or max. Now think about it. Think about it. Velocity before from time equal to 0 to time equal to 0.443 is getting is positive, right? So that means the particle going up, right? But eventually it slows down, and when it hits 0.443 at time equal to 0.443 seconds, the velocity becomes 0. So it stops. Right? Then what happened? Negative velocity. So what happened to the particle? Begins to drop. Right? Drop. That's why finding that point when velocity becomes 0 gives you that critical point to figure out whether it's maximum or minimum. Okay? So here you have it, part C. Right? So now part D. Find the position, find the position of the particle at time equal to 2. And you want to see if the particle is the particle moving toward the origin or away from the origin at time equal to 2. You want to find the position. Now position, how do we find position? How do we find y? Y at t. We have velocity. We want to find position. Integral, that's right. We want to find integral. And we want to find integral of v of t dt And so then we get integral of 1 minus inverse tangent e of t dt. This we can split. We can split into integral dt, right? Minus integral inverse tangent e to the t dt. Okay. Now this is challenging, and I think the problem here is that the problem here is that we will have to solve the indefinite integral, which is a little challenging. What do we do? I mean, right now this is where we have to consider strategy. This is number 3, so that means you can use graphing calculator. Graphing calculator cannot solve indefinite integral, but graphing calculator can solve definite integral. Right? So instead, I wouldn't do it this way. You see, then I realized that way probably would not work, because it will take a long time for me to figure that out. It will be a waste of time. Is that the time? No. So now let me erase this for a sec, and then I want to talk about this. Now, the position of the particle is basically the displacement of the particle away from the original expression, original position, right? Say, for example, if I'm displaced for 2 units, and my original position is at y equal to 3, and I'm displaced 2 units, what's my final position? My original position is 3, but I'm displaced 2 units. What's my final position? I'm at 3. Right? Along the y-axis, I'm at 3. After all this time, I'm displaced 2 units. Where is my position? 2 on top of 3, right? 5, right? If my original position is at 3 and I'm displaced -5, where am I? I'm down here now, right? So this is the thing. Displacement is equal to integral v of t dt from time 1 to time 2. Notice the difference between this and this. This over here is a position equation using indefinite integral, right? But remember, when we do indefinite integral, it's going to come up with a plus c at the end, right? But this one is definite integral. A definite integral gives you boundaries. And that tells you that what's the displacement between the 2 times, regardless where you start with, Okay? So we can come up with the displacement, but now, after we figure out the displacement, we need to add to where we started. Where did we start? Right? That's where we started. So whatever that we come up with in the displacement position, we will add to the initial position. Okay? So the displacement from 0 to 2. From 0 to 2. 0 to 2. Right? 1 minus inverse tangent e to the t. dt. Now, then you can use your calculator, yeah? Use your calculator. y1 is equal to 1 minus inverse tangent e to the x. Right? Graph it. Then use second trace. select what? Select interval, that's right, select interval. Select interval f of x dx, yeah? And it will ask you what the lower limit is. You say, oh, lower limit is 0. Ask you for upper limit, and you will say, oh, it's 2, right? Press enter, and you get an interval. So that will be the answer. So what's that? What's the answer? What do you have? You should have it pretty easily.
-0.36.
You get negative 0.36?
Yeah.
Negative 0.36. So how many of you got that? 1, 2, 3, 4. Okay, so it's negative 0.36. Now, negative 0.36 is not your final position.
Could you add to that?
And add to the initial position. So we will add into the initial position. So we say the final position, y of 2 is equal to the displacement from t equal to 0 to t equal to 2 plus initial position. So in this case is negative 0.36 plus negative 1. So we end up with negative 1.36. So that's my initial position. Clear? Questions?